So we currently have a stock of functions that we know how to differentiate, but it turns out we don't know how to differentiate the inverse functions of those functions, and we need to derive a bunch of those derivatives of the inverse functions. And we have a stock way of doing that, and now I'm going to illustrate that with the arcsine function here, the inverse sine function. So we got a plan, and it's the same plan for every one of these inverse functions. We're going to define the function, in this case the asin of x, as the inverse of the function we know how to differentiate, in this case the sine of x, and then we're going to differentiate the side we know how to differentiate, the sine side, implicitly using the chain rule, and then we're going to use an identity or some other algebraic trick to come up with the derivative of the inverse function as a function of x. So the function we're starting with is y is the angle whose sine is x. So we define y is the asine of x as the inverse of the sine function, and this is the statement that does that in accordance with the previous information on using inverse functions and the definition of inverse function. So the process for these is pretty much always the same. That is, take the inverse function you want, put it on the left, define it as the function that you know how to differentiate inverse, and then differentiate this side implicitly with respect to x. So we're differentiating with respect to x. Dx is 1. Y you have to remember is a function of x, an unknown function of x. So if we differentiate the sine of a thing, we get the cosine of the thing, and then the chain rule says we have to differentiate the thing. And therefore we have y prime in there, and we can solve for y prime, and y prime in this case is 1 over the cosine of y, which would seem like maybe we're done because the arcsine of x is 1 over the cosine of y. However, this is a function of y, and this is y, and what we want is we want the derivative of the arcsine of x in terms of x. So we need to somehow get rid of this y and get it in terms of x, and in this case there's a clever little identity. The Pythagorean identity, sine squared plus cosine squared is 1, therefore we can use this version of that. The cosine of y is the square root of 1 minus sine squared of y. Now you might wonder why that got us anywhere, and the reason it got us somewhere is because of this side. Oh look, the sine of y is just x. Therefore, we can replace sine of y with x, and we end up with the cosine of y being the square root of 1 minus x squared. And with that information, we can replace 1 over cos y with 1 over the square root of 1 minus x squared. And we end up with the derivative of the arcsine of x is 1 over the square root of 1 minus x squared. That same process will work for every one of these inverse functions, and what that looks like is the same for all of these. It looks like on the one side we have the inverse function, on the other side we have the function we know how to differentiate. We differentiate that, and then we come up with a way for eliminating the y, and then we have the result that is the derivative of the inverse function.